Wait.
So, hello everyone and welcome to today's webinar, Bridging Industry with Printed Electronics Design, Prototyping and Volume Production. My name is Tommy Höglund and I'm the Vice President of Sales and Marketing for Ynvisible, and I will be your moderator in this webinar today. Before joining Ynvisible, around 10 years of experience from the printed electronics industry, working for a Swedish research institute called RISE as the manager for their printed electronics arena innovation cluster. And I'm excited to be hosting this webinar here today with such a great speakers and with such a great audience. And I already now would like to take the opportunity to say thank you for taking your time out and staying here with us and doing this webinar together with us. But I would just like to start by saying a few words about Ynvisible. And Ynvisible Interactive is a publicly traded company on the Toronto Stock Exchange Venture List. And being a listed company, we would like to underline that today's presentation contains certain forward-looking information and statements about Ynvisible Interactive. We at Ynvisible, we develop electrochromic displays that are thin, lightweight, transparent, and very flexible as well, and robust. And our business model allows us to help companies and private individuals as well in different maturity stages. We can help you all the way from design and service and prototyping to tailored R&D or training or ideation to production. And we can print these electrochromic labels in roll-to-roll production in high volumes. As you can see right here behind me is our production line in Sweden. And except from printing electrochromic displays, this facility that we have can also offer the mass production of printed electronic components and systems as a whole. And we do offer these services to other brand owners and product owning companies. And this is being utilized today as well by many companies. But I'm pleased to introduce our speakers and agenda of today's webinar. And today's agenda is targeted against to learn more about the potential and understand the impacts of printed electronics and how you can actually get started with your own design and prototyping. With speakers from Material Connexion, Electroninks, and Ynvisible, you will see what services and tools that are actually available already today that you can use to get started and understand your route on your way to your printed electronic solution. And we have Andrew Dent, is the Executive Vice President of Material Research at Material Connexion, and he will talk about emerging markets for printed electronics. And then we have Brett Walker that will actually really talk about prototyping with printed electronics and how you can use different tools to get started and do it yourself. And then Jarno Vermas from Ynvisible will give you the complete picture, talking about everything you need to get started with printed electronics. And we will also have some afterword and news by our CEO, Janne Mikael Kusistu. And he will also announce this, that we already announced an hour ago, that today Ynvisible have released the news of acquiring the business of Rdot AB. So we will hear more about this after today's speakers' presentations. And after that, we will have the question and answer session at the end of the webinar, with all speakers participating to answer your questions. But before we jump into the presentations, I have a few housekeeping items. So I can tell you that today's webinar will be recorded and available on demand. So you can relax and see this also afterward if it's something that is really catching your interest. And you can also find the webinar on all our social media. So please follow us in Facebook or Twitter, Instagram as well, to follow and find the webinars and other materials from Ynvisible. And we have also ask a question function, so you can see it in your screen. It's at the bottom of the screen, and there you could, during the presentations, type in your questions, and we'll try to answer sometimes during this webinar. But if we not catch up during the webinar, we have at the end the question and answer session where we try to deal with it. And sometimes we have a lot of questions, so we have also a survey directly after checking out from the webinar. You can type in your questions there and we will surely answer all questions coming in, both myself and all the experts participating in this webinar. And at last, we like to encourage you to share today's webinar in your social networks as well. So without any further add-ons to this, I'd like to kick things off by welcoming today's first speaker, Andrew Dent from Material Connexion. And Andrew is very used to webinars and to introduce himself. So please, Andrew, over to you.
Wonderful, thank you so much. Just trying to share my screen so you can see me. Okay, so my name's Andrew Dent. I've been running a, hang on, let me find my, sorry, hang on, there we go, there we go. Yeah, my name's Andrew Dent. I've been running a material science and innovation library in New York for the last 20 years. My job has been to help a whole bunch of clients, all sorts of household brands, find innovative and sustainable materials and to help them implement those materials into their technologies and products. I wanted to spend a few minutes this morning just kind of going over where I think printed electronics, printed and flexible electronics are going in basically in the consumer world. You know, obviously there is industry, there is military as well, and they find application. But in the consumer world, I kind of want to go through a couple of different areas I felt were interesting and you should probably know about as where printed and flexible electronics are developing. Okay, can everyone see my screen? Are we good with that? Wonderful, okay. Thanks, Tommy. Okay, so as I said, I run a material science library. We have locations in New York City as well as all places around the world. And the idea is to give access to samples. The idea to sort of touch and feel materials so you can really experience them. Because obviously if you're producing something, you want to make sure that the consumer understands what it looks and feels like. So samples are key for us. We work in all sorts of different industries. Everything that you as a consumer interact with, whether it's home appliances, consumer electronics, home textiles, fashion, automotive, architecture, everywhere. And from that, we get a really broad view about what types of materials and technologies are out there. So we get a sort of understanding of a 360,000 sort of view over the world of materials and where they're emerging and what we find exciting. Okay. So we know, obviously, these types of electronics allow us to get thinner, lighter, a lot more conformable, lower power. But you know, what are the most exciting markets? So for me, I would probably go through these four: medical, supply chain, consumer products, and also packaging. Those, you know, there are obviously others, but for us, as we look to brands and see what some of their challenges are, these are the areas they're interested in. So, so medical. As we've seen most recently, it's a great idea if you can keep the patient out of the hospital. So therefore, how do you do that? You do that by basically creating digitized systems that allow them to put on themselves devices and systems that can then basically monitor them outside of the hospital. So you can make sure that they're kept healthy, and you can also interact with them, but without necessarily making it much more too cumbersome. So doctor fits and forgets it. It interfaces with the body. doesn't require much power, less maintenance. So therefore, these sorts of printed electronics allow those sorts of technologies to be enabled and to allow you to actually do that effectively. Flexible, stretchable, thin, low power devices is basically where we're going. These can get so that they can be put onto the body relatively easily. You can get display systems as well that allow readouts, so it's easier for the consumer to use. So we're seeing that sort of development. Multiple devices on the same piece. This product by Lumia gives an example. I can get heating, I can get displays, touch-sensitive surfaces, all within the same material that flexes and forms around the body, very much like your t-shirt or your jeans do. Okay, with supply chain. Okay, with supply chain, that's really the stuff that you don't see typically as consumers, but for brands, for people producing stuff, it's so important. How do you make sure it's more efficient? I don't want to lose anything on the way. How do I make sure I can deliver just in time so I don't have an overstock? But also, how do I make sure that the product doesn't go through any sort of extreme climate changes? Water, temperature, time. I want to make sure the product ends up in the market right at exactly the right time without spending too time on the shipping container, without going through too much of a change in terms of temperature, that sort of thing. And then also sustainability. There is an interest to try and track everything continually. So for end of life, there's the ability to then see where it's come from and where it can go. Time strips are a great example, whether it's for blood management, whether it is for the little strap at the bottom, in for the mother, ensure that the mother is actually. I'm going to move very quickly because my connection is unstable. So creates that she needs for the baby are done at the right time. They've found that basically 60% of Pakistani mothers do not actually do all the immunizations. So in order to ensure that, these little things will tell you exactly what needs to happen. Okay, so, and also with things like fashion brands, this is Econ ID. They've actually got a system which tracks the fabric and the apparel itself, much like a passport. So in the same way that you know exactly where you've been from your passport, these are small tracking devices that enable that as well. Consumer products. Okay, so obviously, as we know, Internet of Things is this burgeoning, huge system that is going to be potentially taking over our lives, but also just making sure that we can track things and things can respond and enable us to have simpler, more connected lives. The numbers are staggering. But the ones I'm interested in, the ones that can potentially help us without necessarily, improve our lives. So whether it is simply just enabling us to get better sleep, or potentially just to allow us to get better yoga positions. The idea is these types of systems can fit seamlessly and flexibly into our current consumer products and enable us to live better lives while still ensuring that the products themselves are functioning as they should. I gave you 3 different versions there, which was consumer products, supply chain, and medical. The fourth one is kind of like a be careful, just be aware thing, packaging. Now, this is one area where flexible electronics have done really well. And for me as a material scientist and someone who really believes very much in sustainability, I think that we need to be more careful about where we put these printed electronics. They're great, they've been developed to create wonderful new efficiencies, etc. But for packaging, I would be wary. If you are going to choose this sort of electronics for packaging, just try to think about careful use and end of life. So much of our packaging has caused problems in terms of the use of plastic and single-use plastics. So I want you to do, if you're ever thinking of using it in packaging, there's some potential there, but do it carefully. Is it an essential need? Is it a way in which we can certainly get improvement in life, improvement in efficiency, and improvement in sustainability? Just creating a fancy new gadget for packaging, which then only gets used for perhaps 1 or 2 days and gets thrown away, for me is not the best use for this type of technology. So I think very much, if you are going to use packaging, just be careful. Have intelligent use, make sure it's actually worth it, make sure it's basically either ensuring that blood gets there at the right temperature, rather than simply just wow factor, because I feel like with our packaging, we need to be a lot more careful because those sorts of things don't last very long, and it's perhaps not the best use of this incredible technology. Okay, so that was my sort of presentation. If I can bring it back over to Tommy, thank you very much.
Thanks a lot, Andrew, and we're really impressed of your way of speaking, and at the same time moving to a place where you get a better connection. It's a true proof of multitasking. So thanks a lot, and I would like to introduce the next speaker, if I can also share the screen. If Andrew, if you could.
I'm going to stop sharing mine. Okay, now
Yes,
there we go.
yes.
Control now?
So, I think so. Yeah. And there we go. And there we go. So our next speaker is Brett Walker. He's the co-founder and the CEO of Electroninks Incorporated. And Brett has been working quite a long time with introducing tools for people to get started and get working with printed electronics in different way. And the most famous is perhaps the circuit scribe concept and tool. And Brett will give us an introduction to these and other ideas and thoughts from Brett. So over to you, Brett.
Hi, thank you. Can you hear me just fine, and is my screen sharing appropriately?
Yes.
Okay, great. So thanks for the introduction and the opportunity to speak. And yes, I'll be talking about my company, Electroninks. And so our background is we're a unique company. I as well am a material scientist. That's my educational background. And so we offer high-performance conductive materials, specifically for the B2B markets for integrating the supply chain, but as well have a unique direct-to-consumer product in the form of the circuit scribe pen. So we've received Series B investment. We're located here in Austin, Texas, have a large manufacturing and R&D facility here. And so I won't sort of belabor the company background, but so one of the things I'd like to do as far as understanding and contextualizing our company's offerings a little bit better is, so we have our industrial offerings. Specifically, we really focus a lot around EMI shielding, display solutions as well. And then I have additional materials that go into platinum and gold. But one of the big things that we've noticed with printed electronics in general is there's a large but relatively disparate ecosystem of materials that makes it difficult to compete with traditional manufacturing techniques like traditional PCB prototyping, et cetera, because of the way that they're relatively difficult to play with, for lack of a better term. It's difficult to start playing with new materials whenever the barrier to entry is so high in a number of different scenarios. So that sort of informed our decision to have a direct-to-consumer product line in the form of the circuit scribe, which is a roller ball pen. So very simple and very easy to operate. And so we try to eliminate a barrier of entry, typically seen, and then allow people to access sort of this flexible printed electronics, really rich materials ecosystem, and then partner with companies as well that offer unique materials. We are under no illusion that somehow Electroninks will be the end-all of materials providers. We have our own unique materials offerings, but believe the best way for people to understand how to manufacture new items is to give them tools that allow them to work with these materials in unique, creative, low-cost, and low barrier to entry ways. So we did this by launching our own prototyping ecosystem on Kickstarter. Back in 2013, that was a great decision. Nowadays, Kickstarter is a very different platform, but in 2013, that worked very well for us. And it did a number of things, including providing a user-friendly face to our company while we integrate with our more advanced precursor materials into the supply chain, which, as anyone familiar with the materials ecosystem knows, that takes some time and some doing and is a difficult process. So it's nice to have a face of the company that allows everyone to understand to some extent what we do, and also allow them to utilize it in a meaningful way. And so I'll sort of play our Kickstarter video, which I admittedly have gotten a lot of mileage out of, but I won't go through this in its entirety here. So has a nice little intro here. I look significantly younger for what it's worth there. So I'll sort of skip ahead here and sort of go over traditional prototyping tools versus just a rollerball pen on paper. So the rest of that is more towards Kickstarter backers, et cetera. But that was sort of how we had the genesis of the brand here, to sort of introduce a simple way to prototype and use electronics for the average user. And so basically how it works is, so we had a pretty successful Kickstarter campaign. We used that money to get all of our non-toxic certifications, get supply chain put in place. What's great is these actual pins that you see are actually, if you're all familiar with the Sakura jelly roll pins we all grew up with, the metallic flake pins, Sakura out of Japan actually makes our pins for us. So it's a very nice, robust pin with our non-toxic internal formulation conductive ink that's aqueous based. So we allow users to access this all the way down from students who are just learning circuits, so a level of abstraction required isn't there, so a circuit diagram can actually turn into a working circuit versus plugging and playing on breadboards, all the way up to professional designers who already have a good feel for what they want to do and need to understand what an actual flexible hybrid system would look like on paper versus prototyping via more traditional FR4 with copper plating on top, which doesn't really give you a feel for the flexibility and the integration that a lot of what print electronics value proposition is, frankly. So while prototypes are always useful, if you're prototyping and having to make a lot of compromises, it's still difficult to portray to the end user what the ultimate feel of the end device would be like. So we have a number of basic components that go around power, inputs, connections, outputs, et cetera. And then we have customized ones that allow you to, that actually act as a very small through-hole connector, so you can actually plug and play your own devices to create a fully functioning prototype. Now, where we found our primary traction is actually led us towards here is more towards the classroom. So it's a very great and straightforward way to teach this. And then we've also gone into retail and other sectors. So here's a create your own drone device. So the drone is actually made out of cardboard using our conductive ink on cardboard. So when you crash the device, the whole point is you learn by crashing. So instead of just chucking your drone that you just spent a decent amount of money on, you just rebuild it and you actually learn something about the product in that process. So we've had a good amount of success being able to take printed electronics as something that's normally been something relatively esoteric and people that are very familiar with materials and supply chain to something they can put in front of a consumer. And not only can they understand what it is, they can directly interact and make something to make it that much more approachable to a broader audience. So jumping into that, as I spoke earlier, we're under no illusion that somehow magically electronics can solve every materials problem there is. Anyone familiar with the materials ecosystem knows how long it takes to commercialize new technologies and new materials and integrate them into meaningful products. So by creating a tool set that's very accessible via a rollerball pen and pieces of paper, we feel like this gives us a fantastic platform to build an ecosystem off and collaborate with companies like Ynvisible, where we can make this far more accessible to a larger audience, and then maybe people who want to play with materials that have previously not been a part of the regular prototyping palette when it comes to PCB prototyping or something else for electronics, you can now start to play with displays like electrochromics and do something very fun and engaging there, to where we can give them something, but also allow the user the ability to work with these materials. And then I think the most rewarding things we've seen, especially with the Circuit Scribe ecosystem, is seeing what users can come up with in ways that we never imagined, because by giving them a tool set that allows them to build something, the sky's sort of the limit. And we've seen a lot of very unique use cases that otherwise we would have never thought of. There's only a certain amount of problems that we can go after as a company. And so this is one of the things that we released. It was in last year, 2019, regarding one of the collaborations we have an ongoing with Ynvisible. So they provided us some thin film electrochromic display modules, and then just using a microcontroller unit in the form of a lily pad here, we were able to run these just by running circuit scribe lines on paper. And this is just sort of very quick iteration of some fun things that we can do here. So we believe that by incorporating new materials, especially electrochromics, this is an ideal situation of giving the user freedom to express their ideas in a simple way by having an accessible tool set and having a large ecosystem that allows our customers to give us feedback as to what new products could look like based on creative integration of these in simple, straightforward fashion. So we're looking forward to continuing our collaboration with Ynvisible on the co-development of their kits and products, and that has been a very fruitful interaction with us thus far, and look forward to what the future holds there. In addition, on the circuit scribe side, we have a thin film ecosystem. So we plan to roll out a full sticker ecosystem that goes along with what we already had prototyped there with Ynvisible in the form of an 8-segment display. So while the magnetic components that we have currently work well for quickly doing something in a classroom, if you want to have a working prototype that lasts longer than a 50-minute session or a lesson that a teacher's right there for, maybe you want to take something away in your notebook, being able to do this in more of a plug-and-play sticker format makes a lot of sense. And so all this bundles together and sort of tells a nice narrative of then when we start to move into more complex projects and complex integration, like we see with our industrial materials business, where we do precursor-based materials, specifically our particle-free silver, and then we have gold and platinum as well. So we have very low annealing temperatures, very high conductivity, with a lot of use cases here that plug into cell phones for EMI shielding, capacitive touch sensors, bezel electrodes, antennas, etc. But the whole point is, this is a very difficult place for most users to jump off into. You have to have a pretty good access from a resource standpoint, supply chain, etc., to be able to access these. So if we can give users a way to iterate on product designs in a simple and straightforward fashion, we think that products can be iterated more quickly, more efficiently, and then ultimately have better and more creative interactions with the customer as a result. So I'm just sort of going to skip down here to the bottom. And so we're a different type of materials company, and we focus on what we're good at, but we have no illusion that we're somehow this one-size-fits-all partner that provides everything. We really enjoy collaborations with numerous companies throughout the supply chain that make sense, that have unique offerings that really can build a full printed electronics ecosystem, that we can start to approach this from a holistic fashion versus each company just sort of taking off on their own route. So we truly believe that an ecosystem needs to be in place, and the partnerships that we put in place, like that one with Ynvisible, are a step in the right direction for printed electronics and hybrid manufacturing as a whole. Thank you.
Thanks a lot, Brett, for showing this and sharing your insights from working with these tools and what they can actually do to help you get started and see the possibilities with printed electronics. And from Ynvisible, we're also very happy that we announced this autumn a collaboration and that we're looking to see if we can further develop during this year as well.
Thank you.
Yes. So let me share screen again and also introduce the next speaker of today. So our next speaker and presenter today is Jarno Vemas, is the head of design at Ynvisible, and Jarno is really experienced in the field of printed electronics. He started out working with printed electronics in year 2000 when this printed electronics was kicking off in Finland, and was one of the pioneers there, and working in research institute. But Jarno also have a big experience from working in startups and understanding what startup companies might need and how their situation look when going into this printed and flexible electronics. And design is really Jarno's stronghold, and when it comes to design and the way I've learned to know Jarno, he's always emphasizing the importance of that the whole value chain needs to be in there to actually create a successful end product. And today Jarno will share his experience with us and give example of also easy ways to get started with your own ideas using tools and materials that are actually available today. So with these words, I welcome Jarno into the session.
Hello, everyone. Like Tommy just introduced me, I'm Jarno, and today I'm going to show you a presentation about how to use printed electronics, but the sharing of the screen seems to be difficult. Can you see my screen now?
Not yet.
Okay, now, yes, one click more. Now it should be going. So when the title is like everything in 10 minutes, it's about to focus some fields, and it's really like Tommy said that I'm going to present more about my personal experience in this field, but also the technology, what we're offering as an ecosystem. I love the way Brett was explaining what are the key features in this system that we are building now, and really I call it also as a revolution of printed electronics. So in the presentation, I'm going to go first quickly through what is the printed electronics, and then going more deeply what is printed electrochromics. We're going to look some of the samples what we have done together with these our partners, and then hopefully in the end I have some time still to wrap up the questions, and also especially the answers will be after Jani Mikael's part. So won't change the title. No, right. So like Brett was actually showing, the printed electronics has been there for years. It's been already in the 90s, and mobile phones, especially in Finland, was some of the pioneers using these technologies. But mainly it was just like interconnections, flexible circuit board, etc. So here, what I mean for the printed electronics is using the functional materials, which are mainly in the form of ink, so that we can utilize conventional printing machines, which are widely available. And that is really the beauty of this printed electronics. And printed electrochromics fits perfectly to this world. So when going to look printed electronics as a structure, it's more like what Andrew was showing. They are quite often the pictures and presentations, visualizations look very fancy and very complex, but in fact, most of the components still are pretty simple, and they have this type of structure that you have some conductors, and then you have a multi-layer area where the actual magic is happening. And it doesn't matter if it's like a OPV, like a solar cell or sensor or a printed capacitor or something. They have some similar functions on each of them. This is like one of the disclaimers I'm going to say that here I know that there are a lot of people from other field of businesses, not from electrochemical field or electronics. So for some reason, somebody when doing electrochromics must be love a lot of the word electro. We are focusing and following mainly the electrolyte and using electrode word. So the simplest form of electrochromic device looks like this. It has two printed areas based on electrochromic ink. We call these as electrodes. Typically, other one of them is the one which is getting the color, and the other one will be then behaving as the counter electrode. Top of these, we have electrolyte, which enables this. And look, especially on the left, the electrolyte is not covering the entire printing. So when you apply power to the system, what happens, the part, and only the part which is in contact with the electrolyte area, will get oxidized and will get colored. And the other part will be getting more transparent. So this is the typical system. I can rewind that again. This is the typical system with the typical electrochromic materials and the electrolyte what we are using. And then continuing the same structure as the previous one, where the pools are side by side, but you can add easily more segments on it. So you can have several segments, but use still the same counter electrode for all of these active segments. Quite often we hide. So here the pool is where we have the dark blue and not the light blue. So this is only where the electrolyte is located. So if you look these areas, you can see that there is some default in the design, in that sense that if you activate all the segments, the counter electrode is too small. This type of issues you have to deal with when doing electrochromic designs, but everything is pretty simple. Another version, which is maybe the most common one and most versatile in design sense, is the vertical structure, where everything is like in the form of particularly like a sandwich, vertical stack. You have the bottom layer where you have one electrochromic materials graphic, then you have an electrolyte, and then you have this type of biadhesive frame. There's a hole in the middle, and that is filled with the electrolyte. And then this is also like creating the actual display. It's glues when you laminate it, because it has that double feature on it. And then you have just a similar layer in the top, but you have a different graphics. So then you can switch between these graphics. This is a real prototype what we have done together with Epishine, and here you can see the display in the middle close to the soil. So this is a moisture sensor device that you could use in a garden or in an inside house, and all the power is harvested using the printed organic photovoltaic or solar cell, more familiar name for that. That is done by Epishine, a Swedish company, and we provide that display part to this one. So all these power needed to do the measuring is harvested on this OPV panel and then stored inside the Electroninks. And then based on the soil, then the moisture in the soil, it shows either happy or sad face. So far, all these displays and the samples what I have been showing, you can do and utilize those using our materials what we have on the ink kit. So we have there all the inks, including silver electrolyte, electrochromic ink. We have other variety of PAT with coating and without coating, and then also the material for the electrolyte pool. We have also instructions and videos available for that. The vertical structure, we can go a little bit further on that. So these here are using a different polymers. These inks are different. So we are using here blue and magenta colors. On the left, this is already like a more complex design. It's quite a precise, and especially when you had to deal the overlapping of these small letters. So there is not much room for like offsetting these when building the stack. Also on the right hand, we can see already a display which you can find from our temperature threshold sensor label. This one is roll-to-roll printed in Sweden. So difference between this one and what I was showing earlier, the main thing is two components that we are using. Especially electrolyte is non-transparent, it's white, and that allows us to use the carbon as a counter electrode. Again, this is more just for reason to go into the high volume production, and the functions are pretty same still. Then you have seen in some of our presentations, and also that we have a other type of completely differently behaving electrochromic material. Irreversible can be activated only once, compared to this normal electrochromic material, which can be cycled like 100,000 times, or even beyond that, to millions. On the middle, you can see also this label. The design is from the impact label. The display itself and the symbol which will be activated is in the middle, and the outer ring is for the activation lid. So you can have easily multiple functions to the same label. And then back to the powering issues. So typically we need very minimum volumes of current, and also the voltage are mild 1.5 to 3 volts, which fits very well to this world where you have a coin cells or NFCs or OPVs available. So if there is like always which comes the questions with the electronic designers is that how we should drive this display. So the display is really comparable to a capacitor, printed capacitor. So this means that you have to drive it same way. There is a small peak current in it, and then it also stores energy. So once you have the full capacity inside the display, it might also flow backwards to your driving units. But again, those are things when you're trying to make it to the maximum. So in case you just want to show the device and how it functions, the coin cell is really easy. We have the coin cells on most of the samples we have. We have also there like a simple timer. So when you press, it does something, basically switch polarity or other type of things. We have also shown already the NFC chip as a power unit and an organic photovoltaic. Unfortunately, there was not samples of this one yet, but it will be revealed in the next week. Ynvisible will tell more about that. And one great thing, what I would like to really highlight, that as design in electrochromic, it's more than just making fancy graphics on a 2D form. It's something between that and three-dimensional, as you have the animations, you have the timings and pulsing. So this Rdot kit, it enables really easy to go on the Arduino world and start to do prototyping and really nice stuff on utilizing these type of technologies. And this is really close what Brett was explaining also earlier. So then to the summary. In fact, I would copy exactly what Brett was saying earlier. I also believe that we are really seeing a revolution in printed electronics. And earlier, when I start my career in this and exploring these printed electronics materials, we had like issues that the materials were pretty crap. We made something which was functional for a couple of hours, and nowadays we have a very, very wide possibilities to use like barriers and other type of more developed material, the polymers and everything. So also the printing has come further. So I really do believe that we are facing the revolution of printed electronics and printed electrochromics. So thank you.
So thanks a lot, Jarno, for this nice presentation and showing the possibilities to get started in an easy way and try out your own ideas and so on. So, and thanks to all the presenters today, and stay on, because right now we will introduce the CEO of Ynvisible, Jan-Mikael Kuusisto, and after his short presentation of some recent news from Ynvisible, we will have the question and answer session. So please stay tuned, and Jan-Mikael, welcome, the floor is yours.
Thank you, Tommy. Thank you, Andrew, Brett, Jarno. It's great to have people come together for these webinars. And Jarno, can you control the screen? I'll share a few slides. I wanted to say a few words of thank you to all of you in the audience and our speakers. Our webinar series actually has been a success. It has been overwhelming for us in some regards. We did not expect this kind of response. So I'll talk a little bit on what's to come in our webinar series. And then, as Tommy said in the beginning, we had some great news today regarding acquiring the business of Rdot displays. And I want to briefly speak to that news. Tommy already showed the forward-looking statements, but as we are a listed company, YNB is our symbol in the Toronto Stock Exchange venture list. We have some forward-looking statements in our materials. Very briefly to recap, Ynvisible as a company is offering everything you need to get started with electrochromics. This webinar was really focused to you, the design community. And when I look at these people that registered, you're about 140 people that's registered this time. A lot of new names, and I'm guessing that many of you are product designers. So thanks for joining us. You want to get started? Go online, order our kits. We have evaluation kits, we have ink kits. You can get started today. We of course offer our services to you as well to help you get started. And we would not be able to do that if we didn't have a strong network of partners. Electroninks has the Circuit Scribe pen. We fell in love with it the first time we got to handle it. It's important to have those kind of tools for prototyping. Our next webinar will look at partnerships going into volume production and then very critical partnerships there. Also, hats off to Material Connexion. You guys spotted us when we were just formed. So these guys do an excellent job in really delivering new materials to product designers in big global companies and also smaller ones. And I don't know how you spotted us, but you were probably one of the first locations where we sent samples to. So hats off and thank you for helping us spread the message of the technology. So everything you need to get started with electrochromics is in place. As Jarno said, we are ready now. In terms of the webinar, I want to express thank you because it's been a difficult couple of months for all of us. And I know you have screen fatigue. I'm so happy that you have joined us. Last session we had viewers from over 40 countries. So this word is spreading globally. Our guest speakers have included NXN, IP, and Georgia Tech regarding new electrochromic colors. Jarno showed a little bit of that magenta there. University of Lapland talked about designing with electrochromics. Last session, RFID Journal reporter Claire talked about smart labels, and our partner Identiv said how we're combining electrochromics into smart labels. And again, Material Connexion, Electroninks helped us with this one, really focus at you, product creators and designers. Going forward, next week, Thursday, very exciting webinar. Unfortunately, we're not yet able to release the names of the other speakers, but we have some cool things coming out. We will continue on this theme of design. Today was focused on really getting started, hands-on, looking at how that goes into mass manufactured systems, the industrial design side of it. That's our focus next time. So do rejoin us. This is going into high volume manufacture. Finally, 1/5 to 1/6 of our audience have identified them as people who are interested in investing in the field of printed electronics. And to you, in response to your request, we will have a dedicated session for you mid-June, looking at investment opportunities, of course, in Ynvisible, but otherwise the sector in general. And the CEO of IDTechX, Raku Das, will be joining us as a guest speaker. More on that to come. Speaking of IDTechX, May 27th, May 28th, they will have a free virtual interactive conference. Make sure to check that out to learn about the technologies in this field. We will be there. Tommy will be giving a talk on behalf of Ynvisible. Finally, a little bit of news still on the webinar series. We are a member of Printoscent commercialization community. This is a group of companies that have been working together to bring these technologies from lab scale to industrial production. A very impressive list of partners there. You can go to their website and check it out. And they approached us and gave us the honor to host their webinar series. That kicks off June 4th with an introduction to Printoscent. Other topics will include health and medical. Andrew highlighted the fact that medical is definitely one sector where there's tons of opportunity for printed electronics. So check that out. It's one of our core business areas as well. Looking at structural electronics for automotive and 5G, printed intelligence for safety, the trillion sensor movement. So a lot of great stuff coming in response to all this great feedback we're getting from you. Now, to the exciting news today. Today, we announced that we are acquiring the business of Rdot displays. And a few words to that. You can see our press release, but just to highlight, there's a lot of great synergies between combining Ynvisible and Rdot. Who is Rdot? Rdot is a company from Gothenburg, Sweden, also working with electrochromic displays. These guys have done an excellent job in marketing this technology. On a global scale, a lot of electronics companies have been working with their evaluation kits. The beauty of this company and why there's a nice fit to Ynvisible is that this company was born digital. These guys are digital natives. They set up their business around marketing online, selling online. They've done a fantastic job in that. And with everything that's been happening the last couple of months, how we are working these days, we're not out there in conferences, sadly. The old school style that I use. These guys have successfully built business on selling electrochromic displays on online channels and clearly strengthens Ynvisible's approach to sales and marketing with the COVID times and whatever we have going ahead. They have this wonderful evaluation kit that Jarno alluded to earlier. So as a part of this business transfer agreement, we are acquiring their assets. The 2 employees from the company have now joined us. Happy to have them in the team. And also to Rdot's customers. I know that some of you in the audience are Rdot's customers, I would suspect. Really, from your perspective, what we aim to offer is really the route to mass manufacture. Rdot has been doing a great job with you in the prototyping stage. Ynvisible offers the infrastructure and know-how into going into high volume manufacture. But without any further ado, I do want to pass the ball back to Linköping, Sweden, where we have our 2 new team members, Felix and Philip. Let me stop sharing so we can all see you. So guys, if you would like to say a few words and certainly, again, to your existing client base, please say a few words on what does this mean to Rdot, your current services, and also from a contractual point, I know many will be curious. They signed an agreement with Rdot. What happens now? So guys, welcome to the team. Please introduce yourself.
Thank you very much, Ynvisible, and thank you for the kind words as well. So I think, yeah, first of all, the first question was what will happen to Rdot as a company? So yeah, Rdot will continue to exist as a company, but it will effectively become passive in the sales and marketing of electrochromic displays. So as Jan-Mikael said there, all of our existing customers and potential customers, including our assets, will be transferred to Ynvisible. Myself and Philip here will also become employed by Ynvisible to continue those dialogues with our clients. So I think in many ways it will be a little bit business as usual, but we are very happy to be able to, as you said, Jan-Mikael, also offer this route to mass production here in Ynvisible's facilities in Linköping, which we are located right now. Also regarding agreements, in this deal, the agreements aren't transferred. So we need to reestablish all the different contractual relationships between Rdot's customers and Ynvisible. So we're really happy to join Ynvisible. It has been a few months of discussions, and we're really happy that we finally ended up here. So yeah, looking forward to this.
Happy to have you guys on the team. And again, we see a lot of synergies in bringing your skill sets and assets into Ynvisible. So exciting times ahead.
Right.
All right. So let's let Tommy come back onto the screen, and I guess it's time for Q&A.
Yes. So thank you, and really great with this great news. So some of the questions, and I think that all the panelists are very welcome to help out and try to answer some of the questions. And if you haven't already sent in a question, please keep doing it. So one question here is, in regards to flexible electronics design, how are they supplied? Are they individual on sheets, or can they be supplied on rolls? So maybe Jarno have some experience from this.
Yeah, I was just typing to that and answering that. Typically what we have printed as a form of a roll, we of course want to keep it as long as possible in a roll form. So yes, this is the way we mostly deliver the roll printed material.
Yes. Let's jump to one other question that has come in here and see if one of the other panelists could try to assess this one. Possible Achilles heel. What advances are taking place in the coin battery market, like the power source design issue? Andrew Dent at Material Connexion, or Brett, do you have any insights into the battery question, or otherwise I think we at Ynvisible have some ideas.
I'm not sure I could answer that one specifically. Maybe Brett?
So we've collaborated with a few companies here as well. I mean, that's a very good question. I think one of the things that's easy to overlook is the power source, and there are some emerging technologies with printed power sources, et cetera, for roll-to-roll printing. But in general, that is a nascent market and something that does need to be addressed as far as the ecosystem is concerned, considering the trillion sensor market and movement, as Yanni Mikkel brought up. There's no way to do this in a thin film form factor and then throw a coin cell on there. The printed battery market, while there are some small companies starting to emerge, is something that definitely needs to mature for that to be fully realized, or at least have a hybrid of power systems, whether that be a relatively small battery or small thin film supercapacitor plus a photovoltaic panel, as Jarno showed. Something along those lines will have to be implemented to address the power side.
I think we can complement a bit on this one from Ynvisible and our experience and insights working with printed electronic systems together with the displays. I would say that power is always something that we really look thoroughly into to see what is the best fit for the specific solution, I would say. So it's keeping an open mind to it and not just lock yourself to that it needs to be a battery. Of course, many times battery is the best solution, but not always. So, and as you said, Brett, combinations of different sources is also a good way to approach this challenge sometimes. Jarno, would you like to complement somehow, or?
No. I would say that follow the next week webinar and you will have one answer more.
Exactly, yes. Do join us, because we will be showing some cool stuff next time around as well. And I do want to highlight that You saw that in the image Jarno was showing, there was a lemon battery. We offer the lowest power consuming display indicator, visual indicator technology. So as a part of this, the system level power consumption, you can use multiple different new emerging powering types when you have such low power consuming components as an electrochromic display.
Yes.
Actually, one more thing there, that's all right. Just thinking from the brand and consumer side, the challenge with things like coin batteries is that for a consumer, if you want things always to be available, always to be on. And the challenge with an individual battery that then needs to be replaced or just wears out, that can be incredibly frustrating for a consumer. So I think, yeah, the idea of either using photovoltaics, other ways of charging that can be perhaps more remote or mobile will be an advantage. I feel like the coin battery, you always have the fear that when you finally need the product, it's no longer available. And that to me is a challenge. I think yeah, the idea of finding different ways to charge is probably a better thing, because I feel like the coin battery is destined to fail when you need it most. Even if you can go incredibly low power, it always has that chance that you get to the point where you finally need it and it's been powering itself for the last, I don't know how long, and then you need it and it no longer has that. So finding ways that the phone can power it through remote charging or photovoltaics to continually charge is better for a consumer, because for products that are going to be out there for a while, for longer, coin is always has challenges. So I think even if it can be greater power with the coin, as consumers come back to us and say we don't like, or brands don't like that idea, because the idea that their product is failing in some way is terrible for the brand value. So some way in which it's always available to be on. So even though I'm not addressing specifically coin batteries, that is a challenge, is having that remote, discrete object is powered. If that loses power, you lose the consumer's perception of value of it.
Andrew, excellent consumer insights, brand perspective to this topic. I really think you need to join us next week and see what we have in store.
Yes, I think we are running a bit over time, but there's one more question here that I think we could address before we round off a bit, and that is it's directed to Jarno, but I say that all the panelists can jump in if they want. And what is the typical thickness of the transparent silver electrode layer in order for it to be transparent in the electrochromic thin film devices? So this was more of a detailed question, Jarno. Do you have it in your head?
No, I was just wondering, it might be meaning now the conductive layer which we have on PAT films, so the ITO. So it is done in a process, and I guess the thickness is just some like a nanometers or something. It's really thin, but it's very hard and fragile in that sense. But I don't know. I'm sorry. I don't know the answer for that.
We have a display here that you could see how really thin it is, and also flexible still, and so we're talking about really thin layers here.
And if you take the roll-to-roll printed display, that is even more thinner. So I would say the substrates are the most thickest part on printing on electrochromics. Yes. Materials will be less than inks, probably just the parts of a micrometer, like I would say less than hundreds, part of 100.
And then we have one more question left here as well. I'm not sure if I really understand this correctly, but it says, if supplied on rolls, can the designs be sent dry on a continuous roll, or do the designs have to be cut into shapes before shipping? I guess it has to do with maybe the size of the display or the electronic device in general, and it's a matter of what you decide and what type of value chain you are in. I would say, I mean, it's possible to just behind me here, you could see a converting equipment that we have, and here we actually act based on the customer needs, more to say, how to cut it out or deliver it on a roll uncut, because it will be cut later on in the process or so. So I think there are multiple options here, but I don't know if anyone else of the presenters today have some input to this question. So I guess not. So I hope we have answered that question as well. And actually we have finished by answering all the questions for today. And I think I'd like to take the opportunity now also and close this webinar and say thank you to great presentations from Andrew, Brett, and Jarno, and also Jan and Mikael, and the great news of Rdot joining forces with Ynvisible. And I must say I'm very, very happy to have Felix and Philip joining Ynvisible, and hope to meet with you who have joined this webinar, and as well as other customers. So take care, everyone, and have a really nice day or a nice evening, depending if you're where you are. And we'll see you in a week or so when we are in our next webinar. And please do remember to fill in the survey when you leave this webinar. And maybe there is one more question popping up. So thanks a lot and take care. Bye.
Thank you, everyone. Thanks, guys.